Welcome to our channel where we explore the world's most significant events in history. In today's video, we will take a closer look at some of the deadliest and most disastrous earthquakes that have struck our planet since the 20th century. Earthquakes are a natural phenomenon that can have devastating consequences. While many of these disasters have left a mark on our history, the events that followed these earthquakes have helped shape the world we live in today. In this video, we will delve into some of the most significant earthquakes of the 20th and 21st centuries. From the 1906 San Francisco earthquake to the 2011 Tohoku earthquake and tsunami, we will explore the causes and effects of these catastrophic events. We will also look at the human impact of these earthquakes, the loss of life, the destruction of cities and homes, and the aftermath that followed. We will discuss how these events have led to advancements in science and engineering that have helped us better predict and prepare for future disasters. The science of earthquakes, how they happen, what causes them, and how they are measured. Earthquakes are one of the most powerful and unpredictable forces of nature. But what exactly causes them, and how do scientists measure their strength and intensity? Today, we're going to take a closer look at the science of earthquakes. Earthquakes occur when tectonic plates beneath the Earth's surface shift and release energy, causing seismic waves that ripple through the ground. The strength and duration of these waves are measured by a device called a seismograph, which records the seismic activity of the Earth. Seismologists study earthquakes to understand how they happen and to predict future earthquakes. By analyzing seismic waves, they can determine the location, depth, and magnitude of an earthquake. They use this data to create earthquake hazard maps and to design earthquake-resistant structures. Speaking of which, let's talk about earthquake-resistant design. Earthquake-resistant design: how engineers design buildings, bridges, and other structures to withstand earthquakes. Earthquakes can cause massive damage to buildings, bridges, and other structures. But engineers have developed techniques to design structures that can withstand earthquakes. Earthquake-resistant design involves a combination of factors, such as strong materials, flexible frameworks, and specialized shock absorbers. Engineers use computer simulations to test their designs and ensure that they can withstand the forces of an earthquake. By using earthquake-resistant design, engineers can create buildings and bridges that are much more resilient in the face of an earthquake, protecting the people and communities that rely on them. Historical earthquakes: the biggest and most devastating earthquakes in history, such as the 1906 San Francisco earthquake or the 2010 Haiti earthquake. Over the centuries, earthquakes have caused some of the most devastating natural disasters in history. From the San Francisco earthquake of 1906 to the Haiti earthquake of 2010, let's take a closer look at some of the biggest and most devastating earthquakes in history. The 1906 San Francisco earthquake was one of the most destructive earthquakes in history, with an estimated 3,000 fatalities and $400 million in property damage. The earthquake occurred along the San Andreas Fault, which is located along the western coast of the United States. The 2010 Haiti earthquake was another catastrophic event, with over 200,000 people killed and over 1 million left homeless. The earthquake occurred along the Enriquillo Plantain Garden Fault, which runs along the southern coast of the island of Hispaniola. These are just two examples of the immense power of earthquakes and the devastation they can cause. Tsunamis: the link between earthquakes and tsunamis, and some of the most destructive tsunamis of the past century. In addition to the seismic waves caused by earthquakes, they can also trigger tsunamis. A tsunami is a series of ocean waves with very long wavelengths that can cause immense damage to coastal communities. Tsunamis are most often triggered by large earthquakes that occur beneath the ocean. The energy from the earthquake can cause a series of waves that can travel long distances, sometimes even crossing entire oceans. Earthquake preparedness is also a crucial aspect to consider. We should all take necessary precautions to protect ourselves, our loved ones, and our homes in the event of an earthquake. It's important to have a plan in place for communication and evacuation, as well as supplies like food, water, and first aid. Organizations like FEMA provide resources and guidance on how to prepare for an earthquake, and it's important to stay informed and up to date on earthquake safety. Seismology plays a major role in studying earthquakes and predicting future seismic activity. Seismologists use a variety of tools and techniques to measure and analyze seismic waves, which can provide insight into the location and intensity of earthquakes. This data is used to create earthquake hazard maps and to develop early warning systems that can provide advance notice of an impending earthquake. Finally, earthquake-resistant design is an important consideration in modern engineering. Engineers use various techniques and materials to design buildings, bridges, and other structures that can withstand the forces of an earthquake. These techniques include base isolation, which involves placing the structure on rubber pads or rollers to absorb the shock of an earthquake, and structural damping, which uses special devices to absorb energy and reduce vibration. Earthquake-resistant design is especially important in regions prone to earthquakes, and is a key factor in minimizing the damage and loss of life caused by seismic activity. By exploring the science, history, and impact of earthquakes, we can better understand and prepare for these powerful natural disasters. With careful planning and design, and with the support of organizations like FEMA and the work of dedicated seismologists and engineers, we can reduce the impact of earthquakes on our communities and build a safer and more resilient world. That's all for today's video. Thanks for tuning in, and don't forget to like, comment, and subscribe for more content like this.